Chapter 6, Lesson 2 of Advanced Algebra. I want to look at factoring some of these polynomial functions that we'll be looking at. We'll be looking at specifically cubic functions that are factorable. And these are kind of special cases that we can do, but we wanted to go ahead and take a look at them because later on we'll want to apply the same properties even though we're going to use quartics and quintics. And it won't be factoring per se, but it will give us a skill that we'll need to use when we get to those. So we want to factor these, or the instruction would be to put these in linear factor form. In other words, we want to write this polynomial in its factored form. In other words, listing the linear factors that we would multiply together in order to arrive at this standard form polynomial. So the way we want to do this is, again, we can't really factor cubics. They have to be a very special order or a very special kind of cubic. And so if we look at this, we'll notice that what's a common term with all of these? And a common term is x. So we will want to go ahead and factor out the x first. So if we take the x out, and again, factoring is just going to be distributive property in reverse. We're going to divide each of these by x, and that's going to leave me this. Now you'll notice when I factor out this one x, that leaves a quadratic inside this parentheses. And whenever I have a quadratic, I always want to look to factor that. So this is one of our cases where this leading coefficient is a 1, so I know that this is going to be x and x. So then I'm looking for factors of negative 20 that add up to a positive 1. So that's going to be a positive 5 and a negative 4, because 5 times negative 4 is negative 20, and then 5 plus negative 4 is 1, which gives me the middle term. So this would be the factored form of this cubic, and all of these are linear factors. This is a exponent of 1, so it's linear. This binomial has the highest exponent of 1, so it's linear, as is this. So these are the linear factors of this cubic polynomial, and that's what we want you to be able to do in this lesson. So I have 10 examples that I'm going to do here, and I have the answers right here so you can kind of see where we want to end up, but I will explain each one as I walk it through. So you can watch as many as you need, and then that will wrap up this video. So in this term here, or in this polynomial, again, x is common. So I can factor out that x, so that's going to remove 1x from each of these. Now this leaves a quadratic in here, again, that I want to factor. So again, because this initial coefficient is 1, I know this is going to be x and x. And then this is actually a perfect square, so I could either write it like this, or the more kind of conventional way to write it would be this squared. So this would be that cubic factored. And again, each one of these is a linear factor. All right, we'll go ahead and take a look at a couple more. All right, for number 3, again, these are all going to be very similar in that they're all going to have an x, which is easily factored out. So we're going to take out that x, leaving me this quadratic inside, and then again, all of these quadratics, I have a coefficient of 1, so I know this is going to be x and x. So factors of 10, negative 10 that add up to 3. So a positive 5 and a negative 2 would be my factored form. And I'm just going to do one more and we'll just call this. Now, call this a lesson. Again, what's going to be common here is the x, so that's going to take out x squared minus 1 then. Now this is a difference of 2 squares. This is one of those special ones that we learned about. And a difference of 2 squares always factors into x and x, 1 and 1, and then one of these is plus and one of these is minus all the time. And you'll notice the order doesn't matter because we're multiplying these together and multiplication is commutative. Okay, I'll do a couple more. As we look at number 5 here again, we have an x that's common to both of these, so we can factor out that x, leaving me x squared minus 16. And again, this is one of my special cases. It's a difference of 2 squares, so that's going to factor into x plus 4 and then x minus 4. All right. In number 6 here, again, we have a common x term in all of these, so the x can be factored out of each one of these. And then again, I have a quadratic that I want to look to factor. So because that leading coefficient is a 1, I know this is going to be x and x. Then I need factors of 20 that add up to 9. That's 5 and 4. 5 times 4 is 20. 5 plus 4 is 9. Okay. Number 7, again, here we have a common factor of x, so the x is going to be factored out. And then always want to look for, and this is really the key to this whole thing, is that I want you to kind of understand, is that we always want to look and see if we have a quadratic here. We want to factor this last quadratic. We need to keep factoring until we come up with everything that we need, or until we can't factor any further, and that's usually where we're going to end up with all linear factors here. These are all going to be linear. In number 8, again, x is common, so we're going to factor that out. Now, and again, if I take the time to look at this, this is a perfect square. This is the square root of this is x. The square root of 25 is 5. 5 times x is 5x, and that times 2 is 10x. So to factor the perfect square, I take the square root of that term, the square root of this one, and then I use that term right here. So this would be the factored form. All right, I have 2 more that I'm going to do for you, then we'll wrap this up. Number 9 here, again, we have a common term of x. It's going to be in all of these, x squared plus 8x plus 16. And then again, this quadratic we want to look to factor. This is a perfect square. X and 4 is 4x, doubled is 8x. So I take the square root of the 8x, the square root is 16, and then we use that sign there, and so we have the perfect square. And finally, number 10 here, again, x is the common term. We want to factor that out, and then we always want to look for this quadratic and make sure that we factor the quadratic if we can. This is x, factors of 6, negative 6, that add up to negative 1, would end up being this. Alright, so hopefully that was helpful, and again, you'll always want to look for a common term whenever this is a cube to see if you can't create a quadratic which you can then factor, and then that gives us the linear factors of the polynomial.